Hornets, thank you for joining me today. Today we're going to be taking a look at our, I just lost it. There we go. Our chapter test for chapter 5, and this is the second one that we're doing. Be aware I'm only going to be working on part 1 today, which is 1 through 9, the first side. Unfortunately, I'm running out of time, and I'm going to need to continue to do other work, so we're going to break it up into 2 parts. All right, please be aware of that. For those of you hoping that I get it all done tonight, I wish I could say I can, but I cannot, and you will have to wait until tomorrow. Alrighty, so we're going to be starting off with the first one, and you'll notice we are working with x equals 6 sine theta. We're going to be using our trigonometric identities to substitute into this and simplify it all the way. Please take note that we are looking at 0 to pi over 2, and cosine and sine are both positive. As a result, at some point in time, we are going to be getting an absolute value, but because a negative is not possible, we will drop the absolute value. Alrighty, here we go. In number 1, what I would recommend that you do is you start off with the 36 minus. Put parentheses and a squared. Inside of this parenthesis is where the x will go, and we are replacing the x with the 6 sine of theta. We're now going to square the 6 and the sine of theta, leaving us with 36 minus 36 sine squared of theta. I now have a GCF that can be factored out, leaving me with a product, 36 times 1 minus sine squared theta. Now, we know that the Pythagorean theorem says that cosine squared plus sine squared equals 1. So if I subtract both sides by sine squared, I end up with cosine squared is equal to 1 minus sine squared. We're going to replace the 1 minus sine squared with cosine squared theta. I can now take the square root of both pieces, leaving me with 6 times the absolute value of the cosine of theta. But because we are working with 0 to pi over 2 for our theta, a negative is not possible, and the absolute values can be dropped. Be aware, if I had used 0 to pi, the absolute values would need to remain, since cosine could now be positive or negative, and we only want positive results. Number 2. Number 2 is an identity, or a verification of an identity. And we are looking at cosine theta times cotangent theta divided by cosecant theta equaling 1. Minus 1 equals the negative sine squared of theta. Now, when we're doing this, I always recommend that students work by separating pieces if possible and replacing them with their ratio identities first. We also can see that we have a reciprocal identity. And once again, we are going to show that this is the negative sine squared of theta. Now, once I replace my ratio identity of the cotangent, which is cosine of theta divided by sine of theta, and my reciprocal identity, 1 over cosecant, is the sine of theta, I can clearly see that the sines of theta are canceling, and I have a cosine squared of theta, minus 1. Now, we just went through this idea that 1 minus sine squared theta was cosine squared theta. Well, we can also make the statement that our sine squared of theta is equal to 1 minus cosine squared theta. So if I factor out a negative, I have 1 minus cosine squared theta, which I can now replace with our sine squared theta, and I have shown that they are both equal. That is number 2, verifying the identity. We're now going to go ahead and take a look at the next problem. Our next problem is number 3. This is a solving, very similar to problems that we have seen in the past. And we can clearly see that we are looking for any of our solutions, not just a small number. We're also going to be working from in terms of either radians or degrees, and it's your choice which one you want to work with on this test. So let's write down the problem. 2 sine x minus 1 equals 0. I'm going to solve for the sine of x. I'm going to do so by adding 1 and dividing by 2. We are now looking at or thinking about our ratios from the unit circle. We know that the sine of x is 1/2 at 30 degrees in the first quadrant and is also 150 degrees in the second. In terms of radians, this would be pi over 6 and 5 pi over 6. Since we want all of our solutions, we're going to be writing it as 30 degrees plus 360 degrees k, where k is an element of the integer set. This gives me all of those equivalent coterminals. We then have 150 degrees plus 360 degrees k, and we have the two solutions. If we were doing it in radians, we would have pi over 6 plus 2 pi k and 5 pi over 6 plus 2 pi k. Now, if we were given a domain, we would have to add our rotations until we get outside of that domain. This is where we have multiple solutions. We're now going to number 4. Number 4 says verify the identity for the cosine of alpha minus the cosine of beta, and I have the sine of alpha plus the sine of beta plus the sine of alpha minus the sine of beta divided by the cosine of alpha plus the cosine of beta. Now, ideally, what I would like to do is I'm going to be multiplying by conjugate pairs, or first trying to get that identity. The denominator needs to be the same. So if I multiply the top of the first fraction by cosine of alpha plus cosine of beta, and I multiply the second fraction by this denominator, sine of alpha plus the sine of beta, I'm going to end up with a common denominator. Sine of alpha plus the sine of beta times the cosine of alpha plus the cosine of beta. But more importantly, notice what I have on top. I have cosine squared alpha, and I'm subtracting cosine squared of beta. I am adding to it the sine squared of alpha minus the sine squared of beta. Now, when I look at this, I can see that cosine plus sine is going to equal 1. So the cosine squared alpha is going to be moved so that I have the sine squared of alpha next to it. Notice that I now have a negative cosine of beta and a negative sine of beta, so I'm going to factor out the negative, and I will also then have a cosine of beta plus the sine of squared of beta. Now, these are our Pythagorean identities. Let's just go ahead and put sine alpha plus sine beta times cosine alpha plus cosine beta. Since this first numerator is 1 right here, and I am subtracting 1, it is over the denominator, sine alpha plus sine beta times cosine alpha plus cosine beta. All I need to do is look at the numerator, and you'll notice I end up with 0. 0 divided by anything is 0, and therefore I have now proven my identity. We're now going to go to number 5. Number 5 is another solving question. We are looking at trying to solve, and once again, you'll notice we are not given radians or degrees, and we are not given a domain. So we are going to find all of our solutions, not just the ones between 0 and pi over 2, or pardon, 0 and 2 pi, or 0 degrees to 360 degrees. We're going to start by writing 2 cosine of x plus root 3 equals 0, and we are going to solve for the cosine of x. This gives us negative root 3 over 2. Now we know that the cosine is negative root 3 over 2 in the second and the third quadrant. In the second quadrant, we are looking at a 50-degree reference angle for 150 degrees. This is 5 pi over 6. We also can then find in the third quadrant, 30 degrees plus 180 is 210 degrees, which would give me 7 pi over 6. Now I can find all of my answers. 150 degrees plus 360 degrees times k, and 210 degrees plus 360 degrees k. If we were working with radians, we would have 5 pi over 6 plus 2 pi k. And then 7 pi over 6 plus 2 pi k. Once again, if we had a specific number or a domain, we would then add k equaling 0, 1, 2, or however many until we get a value that is outside of the required domain. We're now going to go to number 6. 2 cosine squared x equals 1 minus cosine of x. This time we are given a domain, and our domain is between 0 and 2 pi. So we are in radian mode, or we will be using radians as our solutions. I'm going to go ahead and I'm going to add cosine and I'm going to subtract 1. 2 cosine squared x minus cosine of x minus 1 plus cosine of x minus 1 equals 0. Now, some people are going to want to use a u substitution, and we're going to let u equal the cosine of x. This will give us 2u squared plus u minus 1. And some people will find this an easier method of factoring. Go ahead and use a u substitution anytime you think it's helpful. We're now going to factor. I have a 2u times a u, and that gives me 2u squared. In order to get a 1, I have a 1 times 1. Now we have to make sure that we end up with a positive 2u. We already know that we're going to have to use a plus or a minus. If I multiply 2u by a positive 1, I get a positive 2u. If I then have a minus here, this u will multiply by u to give me a minus 1u, and 2u minus 1u is the positive 1. We're now going to put our cosine back in, so that 2 cosine of x minus 1 is equal to 0. By our 0 property, one of the two factors has to be 0. Oops, and let's put our cosine in. So we have cosine of x plus 1 equals 0, and I'm now going to solve. Cosine of x equals 1/2, and the cosine of x equals negative 1. In radians, we know that cosine is positive in the first and the fourth quadrant. In the first quadrant, cosine is 1/2 at pi over 3. In the fourth quadrant, we would take 2 pi, subtract pi over 3, and we get 5 pi over 3. We then look at when is cosine going to equal negative 1. This is sitting on the negative x-axis at the coordinate negative 1, 0. Since x is our cosine, pi is our answer. Now remember, if this happened to be in degrees, we would be using a 60-degree angle, we would have 300-degree angle, and we have a 180-degree angle. So in radians, our solution is here, and in degrees, our answer is here. Let's now continue with number 7. Let's just take a quick look at it again. Notice number 7 is giving us information, and we are trying to find the exact value for the sine of u plus v, cosine of u plus v, tangent of u plus v, and then the reciprocals. We are told that the sine of u is 11/61, and the cosine of v is negative 40/41. We are also told that u is a negative cosine, or cosine will be negative, and the only place where sine is positive and cosine is negative is in the second quadrant. For the second, we have a negative cosine, but we have a positive cotangent. This can only happen in the third quadrant. Once we know the quadrant, we want to make sure we draw the reference angles appropriately. So here we go. In the second quadrant, our reference angle is going to look like this. Angle U goes all the way out here, and this is U. We know that we have an 11 for our opposite side, and our hypotenuse is 61. We are therefore looking at the square root of 61 squared minus 11 squared. Let's find out what that value is. Using our calculator, I am going to put the square root. Let's try that again. Let's try that again. There we go. The square root of 61 squared minus 11 squared. Now I'm going to hit enter just to see if I get an even number. And I do. I now know my x will be a negative 60. Notice it's negative because we are in the second quadrant. I therefore know that my sine, which was given to me for u, is 11 61st. The cosine of u is going to be negative 60 61st. We then have our tangent of u, which will be 11 over negative 60. We're now going to go to the third quadrant and draw our reference angle, and this is for v. Now we know v starts at 0 and goes all the way around to the terminal side. We are also given the ratio for that for cosine, and the cosine in the third quadrant is going to be a negative 40 over 41, the hypotenuse. We're now going to set up the sine, or this opposite side, which is going to have to be 41 squared minus negative 40 squared. This is by the Pythagorean theorem, and once again, we're going to hope that we get a very nice number. We're going to try with square root of our 41 squared, and we're going to subtract parenthesis negative 40 close parenthesis squared. Luckily, we get a 9. We now know that our cosine, which was given to us of angle V, was, and still is, negative 40 41st. Our sine of V is going to be 9 41st, and it too is negative in the third quadrant. The tangent that we are given is going to now be a positive 9 over 40 because of the double negative. We can now find our various pieces using the sum and difference formulas that I have expected you to learn. The sine of u plus v is going to be the sine of u cosine of v plus the cosine of u times the sine of v. We are now going to replace exactly with what we have. 11 over 61 times negative 40 over 41 plus the cosine of u, negative 60 over 61 times our sine, which is negative 9 over 41. Now 61 times 41 is 2,501, and it will be a common denominator between both fractions. When we do the 11 times the negative 40, we end up getting a negative 440. The double negative here will become a positive, and we are simply looking at 9 times the 60. We end up getting 540. Notice that when we subtract, we end up with 100 over 2,501. I'm going to leave it like that. If I tried to reduce it, I could very easily cause problems, and I'm not too worried about it. We're now going to go to the the cosine of u plus v. Now the cosine of u plus v is cosine u, cosine v, minus, notice they're always opposite, sine of u, sine of v. We're now going to do a direct substitution. The cosine is negative 60 over 61. The cosine of v is negative 40 over 41 minus the sine of u is 11 over 61 times the sine of v, and the sine of v is negative 9 over 41. Notice that we will have a sum because of the double negative, and we will also have a double negative. Notice the product will end up being the same for both. So I'm going to go ahead and put down 2,501 and save myself some time. When I am multiplying by the 60 times the 40, I am getting 2,400. Once again, we have the sum, and we have 99. I end up with 2499 over 2,501. Now, when we are working with our cosine of this, the tangent of u plus v, I'm going to rewrite it as the sine of u plus v over the cosine of u plus v. This will give me 100 divided by 2,501 over 2,499 divided by 2,501. By simply multiplying by 1, 2501 over 2501, the denominators are canceled quickly, and our answer is 100 divided by 2,499. Now, in order to find my cosecant, all I do is take the reciprocal. So the cosecant of u plus v is the reciprocal 2,501 divided by 100. The reciprocal of the cosine is the secant, so the secant of u plus v is going to be the reciprocal of this value right here, and that's going to give me 2,501 divided by 2,499. The last one we're going to find is the reciprocal of our cotangent, and that, of tangent, which is the cotangent of u plus v. We end up taking the reciprocal of this, and we have 2,499 divided by 100. These are now the four values that we were seeking at the beginning. Notice, in order to find my cosecant, cotangent, and secant, I want to make sure that all I do is take the reciprocal, and that means that all of the work is done in finding the sine and the cosine. Since I use the tangent uses the sine of u plus v over the cosine of u plus v, I don't have to do any extra work to find my solution. These are the four, and I'm now able to move on to question number 8. So again, here, let me just give you a moment to look at what I did. I started off identifying the quadrant. I used the Pythagorean theorem to find the missing side based upon the quadrant we're in. Once I have it, I can set up my ratios for sine of u, cosine of u, and tangent of u. I then repeat the process in the third quadrant with the v. Once I have my missing value using the Pythagorean theorem, I set up my cosine of v, sine of v, and tangent of v. I then go to the formulas for the sum and difference for both sine and cosine. I have no choice but to learn those, otherwise you will not be successful. Once I have my two ratios, I can then use those two ratios with my tangent of u plus v, since it has to equal the ratio identity. Putting in those values that I found for both, the denominators automatically cancel, and it is simply the numerators that I'm working with. To find the cotangent, I take the reciprocal. To find the cosecant, I take the reciprocal of sine. And to find the secant, I take the reciprocal of the cosine. Number 8. Number 8 is asking me to use the sum or difference identity in order to find the sine of 3, 4, 5 degrees. And we're trying to verify or show that it is negative root 6 plus root 2 divided by 4. Now, we have to know our sum difference identities, and if I'm looking at this, I can say that I have 300 degrees plus 45 degrees. This is what I am going to work with for the sine of that angle. I know that my formula has to be the sine of 300 degrees times the cosine of 45 degrees, and I have a plus, and now I'm working with the cosine of 300 degrees and the sine of 45 degrees. Once again, we are required to use our ratios in order to do this. Now we know that the sine of 300 degrees is a reference angle of 60 degrees, and so I'm using negative root 3 over 2. The cosine of 45 degrees is root 2 over 2, and I have a plus. The cosine of 300 degrees is 1/2, and the sine of 45 degrees is root 2 over 2. When I multiply, I get root 6 over 4 plus root 2 over 4, and since they have the common denominator, I can put them together. I have now verified that, and yes, indeed, the sine of 345 degrees is indeed negative root 6 plus root 2 divided by 4. The last problem that we have is a double angle formula, and I have asked that you learn these formulas as well. So if I'm looking at the exact value for the cosine of 2u, and I am given, let's just show it, I am given that u is equal to, sine of u is 3/5, and it is in the second quadrant. I want to draw that reference angle very quickly. So we're going to go into the second quadrant. Here is u. The sine was given to us as the sine of u is 3/5. I therefore know I have a 3 and a 5, and this is my minus 4. So I can now identify that the cosine of this angle u is going to be negative 4/5. Now the formula that we are going to use, we have several. After all, we know that we are looking at the cosine squared of u minus the sine squared of u, or we can use one of those other identities that we have already gone over and have utilized. Keep in mind, all I would need to do is put my cosine identity here, and I would end up with 1 minus 2 sine squared of u. And if I replace the sine squared of u with the 1 minus cosine, I end up with the 2 cosine squared of u minus 1. So we have our three identities that we can choose. I can use 3/5 or negative 4/5 in either one, or I can put them both into this one. It's your choice. I'm going to go ahead and I'm going to take a look at my first option. So I have 1 minus 2 times 3/5, the quantity squared. That would give me 1 minus 2 times 9 divided by 25, which would be 25 minus 18 over 25, and my answer would end up being 7/25. If I decided to use the third one here, I would have 2 times negative 4, negative 4, 2 times negative 4/5, the quantity squared, minus 1. This gives me 2 times 16 over 25 minus 25/25. Now that I have the common denominator, I'm looking at 32 minus 25/25, and I once again set 7/25. And I'm not going to bother doing the first one, as I've already done it twice. You get to choose. Just remember, you have to go back to the unit circle, or to the reference triangle in quadrant 2 that was identified in the problem. by u is between pi over 2 and pi, the second quadrant. Once again, here's u. This has been the first part of the practice test number 2, and tomorrow I will be doing numbers 10 through 15 in part 2. I hope this has helped. I hope you enjoyed this. If you liked it and you felt it was useful, please click like and watch it as many times as you need to so that you get used to it. Hopefully between test number 1 and part 1 of test number 2, you are starting to feel more comfortable. Thank you very much, Hornets. Be well, take care, and please remember it is easy to be mean, so try to think about what you say and what you do so that we can be nice to everybody. No one needs to feel slighted. No one needs to feel bad after communicating or working with anybody. Thank you, and good night.